Thanks a lot. So, in this webinar, I think you would be sharing your experience along with the general questions what as a mechanical engineer gets. Am I right? To start with, I'll just have a short introduction about Arjun. So, he has very skilled person in the mechanical engineer. Mainly, he did his aeronautical engineer from Hyderabad itself. Now he is working in US in healthcare. So he will explain, elaborate each and everything and the hurdles, whatever he faced in the journey of 13 years experience, and how you have to make a plan or a proper agenda for your career. So it will be very useful. So that is why we are bringing our experts here to clarify most of your doubts. Please feel free to ask if you have any questions. He is ready to answer. Okay, Arjun, thank you, Arjun, for accepting our request again. I'll hand over to you the session. You can start now.
Thank you very much, Sunita. First of all, before starting, as I said, I would like to thank you, Sunita, for actually having this session scheduled, because as when we were starting off as engineers, we always had a lot of questions about what the path that we are taking, or the mechanical engineer in a whole itself. Coming out of engineering as young people getting into jobs, we had a lot of doubts to which stream to choose, or what excites us, or what is the path that we would take. And so we didn't have an opportunity back then. So I thank you first of all to have a platform as such put together for some people. It might help at least some of the people that who are looking for answers.
Yeah, definitely, Arjun. It's a great opportunity. Since we don't have the guidance we are providing now, which is a great opportunity for the attendees, basically to clear all their doubts. Majorly, most of the mechanical engineering students will have tons of questions. Where to go, which direction to go. If we share our experience, it will be a great benefit.
Yeah. So hopefully I'll get through as and thanks for the introduction, Sunita. So as Sunita said, I would actually go through my experience from my college days, and through all the experience of 13 years working with different sectors of aerospace industry, renewable industry, and also healthcare industry. And while I go through, please feel anyone who would like to have any questions, please feel free to ask any questions that you would like to be answered. I would like to be an interactive session, so it's not that I have to complete something before you ask questions. So let's make it a conversation rather than a presentation or such. Okay. So basically, I'm an aeronautical engineer by education. So I've joined Institute of Aeronautical Engineering, which is in Dundigal. So I've studied from 2005 to 2009 there, and after that, because of I think 2009 was a very hard hit for the whole world because of the recession that we had, and we didn't have much job opportunities back then, giving that skittish market that we had back then. So after that, I think I've got an opportunity to work in a engineering college as an assistant professor for 1 year. It was Maheshwara Engineering College in Isnapur. So I actually went there to teach for 1 year. So funny thing was, what I discovered in teaching is that engineering was not hard as I thought while the 4 years while I was studying, because I understood that I never opened the book. Okay, so I never read the book, so it was pretty hard. But when I had to teach, I had to know things before I taught them. So I had to open the book and read that. So it was not so difficult as I thought when I was doing engineering to get marks or to understand theory or something like that. You just have to go in a mood of understanding things and teaching someone instead of getting marks or getting things. When you think of getting marks and stuff, what you do is you refer to, I don't know if you people still have spectrums and guides and previous papers and stuff. So we just mug up things. You go to certain questions, certain important questions, certain important topics, and you start taking those in and spitting it out for answers. You might get your degree, you might get your marks, but the knowledge actually has a gap there. So I definitely, first of all, before I jump into my experience, if you're still studying, or if you're still looking for jobs and you feel a bit shaky on your basics, I definitely assure you, just go through the basics as starting as from the start of the book. I think that might give you a lot of help. So don't study for your marks, but just study as if you are going to teach someone, that a responsibility on your faults, that you have to tell them and make them understand what you've understood. So take, like, for suppose, don't take your friend from engineering, take someone from inter, or some brother of yours or cousin of yours who is actually studying in a lower classes, and try to explain what you understood. If he understands, then that's it. That's all that you want to get from engineering. So
Arjun, here I
that's,
have a question. Sorry to interrupt.
yeah,
So, like you said, we have to study the books. So we have so many subjects in semester. I think about 8 subjects and 4 years. So, which subject is preferable, main?
see
What
that
we
that's
have to
see
focus on?
Exactly. That's a nice question, because as students, we always have this notion of, we study a lot, but we don't use anything while we do our work. For suppose you study matrix, you study algorithms, you study algebra. There's sort of a lot of things that you study, a world of things that you study. But I don't think most of the jobs would never use anything. For history itself, I don't think we will be using history as engineers. So basic engineering is something, a platform. So it's a big basement that you ought to build, and from there you can actually build on any of the surfaces. For suppose, being an aeronautical engineer, you might need much of fluid, FOM. I don't know what's it's called now, mechanics of fluids. If you're coming to structural engineering, you might more need a base of MOS, that is mechanics of solids. If you are a thermal engineer, you might need support of what we say, the thermodynamics. Okay, so if you're someone who is actually drafting things and stuff, like you're into UG or you're into CATIA, that makes a lot of help when if you had engineering drawing knowledge. But one thing I would like to tell you is that have basics of everything ready with you. It's not that you have to concentrate on one single subject, because you're not going to go in depth with any subject that you have in engineering. What is taught in engineering is as a basic. But for you to be a mechanical engineer, what I really believe is you have to have a knowledge of combined, a basic knowledge. I'm not saying you have to be a topper in, or very well scholared in thermodynamics, as well as MOS, as well as MOF, or whatever it is, mechanics and engineering and everything. But you should have an initial basic, a strong understanding of the subject, and basic theorems, basic understanding of what's going on. Like, I think when I get into my experience, I can give you an examples of how different subjects actually gave me strength to actually work and go forward. So to answer your question, Sunita, engineering is all basics. So it's better to have your basics done. It's not that you have to concentrate on one single subject, because after engineering, you might not know, if you are very well focused in getting your single job. So for suppose, if you know your field, and if you want to work for that field, it is better to actually study that subject more. But given the market condition, given the opportunities that we have, we are not sure which sort of industry that we would get into. So I would bet it's best to have all the basics in. All this, I don't expect you guys to actually do well 90% or 100% in your subjects when it comes to every subject, but 75, 60, 50 is good. But you have to have the basics. That's it. That might answer your question.
Yeah, definitely. Thanks a lot, Arjun. It means that we have to understand, at least if we have a actual scenario, we should know where we have to refer finally.
Exactly. And
We should know which
another
subject we have to refer and where we have to refer for that. So at least if we know the basic knowledge where we have to refer, in that subject we'll be referring to go
exactly,
in depth of what we are doing it.
exactly. And
Yeah.
and to just to build on your point, one thing I would like to elaborate is that in this in this world now, in this 20th century, or in this 2020 2022, information is not hard to get. So you can Google things, you can actually spend some time and get information. You need to know where to look, how to actually look at it, and how to understand and put it into the solution that you have. For suppose, for a small example, you have some condensation on your door or something that you want to check it out. You need to know just what to look at. You can't go and look at subjects which are totally different, just because there is a lot of information on hand. You'll have a lot of experts. When you get into jobs, you can talk to experts. You need to know whom to contact, what to talk about and stuff. So it's not that you have to mark, because for me, after 13 years of experience, you don't really expect me to what we say, really
Remember the
spit out.
formulas. Yeah, remember
Yeah,
the formulas
exactly.
of stress and all.
Yeah,
But
the
how it
bending
is happening
stress.
and all, we should. Yes.
Exactly, the bending stress, or shear formulas, or the flow equations. You don't expect. I don't think anyone expects me of remembering those. That's the responsibility of a computer to do. It's not mine. My responsibility is to interpret what a computer says, and to give a solution to the prescribed problem. So that's how I look at it.
Yeah, thanks a lot, Arjun. It answers my question in detail.
Okay,
Yes.
thank you, Sunita, for asking that question. So just to, I think we've slightly derailed. I guess I mostly might not be on a larger scale, but I slightly derailed, I guess, from the agenda. So to get back to the agenda, I've teached about for 1 year in Maheshwara Engineering College for from 2010 to 2011, I guess. So with my help of some of my seniors and some of my neighbors, I could actually get an interview opportunity at Scient Hyderabad. It's in Manikonda. So I joined them in 2011, and in Scient India, I worked with them for 2016. So while I was working with them, I had an opportunity to work on softwares like ANSYS. Basically, the main strong part was work. I was working with ANSYS Classic, and I was working with UG. So majorly, as coming to the client, Pratt and Whitney, it's an aircraft engine company. It's been around since the World War II era. So it's been producing a lot of engines for in the World War II era, also for a lot of fighter aircrafts, and now it's into commercial and defense system. So most of the A320, if you know of A320 aircraft engines, so those are produced by Pratt and Whitney. So we had an opportunity to work on the high-end technologies of aerospace industry. And if you are good with your basics, I think your general turbojet engine consists of your compressor, your combustor, and turbine. So it can be divided into many other parts. So you can have a low pressure compressor, high pressure compressor. You have a combustion. You have a high pressure, low pressure, and high pressure turbines. You'll have cases. You'll have igniters and everything. There'll be a lot of groups working in a different sectors. But I had an opportunity to work on components like the high pressure turbines, turbine blades, and the cases. I had opportunity to work on other static parts and dynamic parts in that. So basically, we used to have the models. So back then, when we were starting off as engineers, it was our responsibility to do all the dirty work. So all the mechanical labor work, if you may say, that is to mesh the model, to apply forces, the basic things that you learn when you get into CAE modeling and stuff. So mesh the model, cut the model, mesh the model, have proper mesh assigned, loads assigned, and solve the model, interpret the results, mostly just spit out the results and give it to someone else to interpret it. So I actually had that opportunity to do for the first 6 years of my experience. So what that taught me was to actually work under pressure, and actually given me a sense of all that, how the dirty work is done. So as when you grow in engineering field, you might not need to get your hands dirty in the sort of work where you mesh things, you apply things, but you will, after, I think, you do such a lot of vast work for 6 years, you will start understanding, interpreting the results on your own, start just trying to understand the global things of what's happening and stuff. So you might be on a single component, working towards something big, but you might not know because you're on a low end. So that was my job for the first 6 years. So basically, it was to predict the life of the turbines. So how much time it would stay in air or stay in operation before it has to go to service, and the integrity of the model holds up till how many sorts of flight hours. So basically, when it comes to any mechanical component, it is generally uh, uh, the time that it can actually service or actually be in what it can work. So for suppose if you have a car, okay, generally they give you a warranty period of I think 100,000 miles or 2 lakh kilometers or something like that. So what is the limit that this engine can go is what we were ought to do. And because it's an engine, if it's a car, if there's a trouble, you actually park on the road, just get onto the road and park and call someone to get to home. But in the case of aircraft engine, that's not the case. You can't park your aircraft somewhere when you're in the air. So it's something very, very critical to know up till when the part can stay integrated and provides you proper functioning. So that's what I did for first 6 years. And as the client, Pratt and Whitney, was based out of US, we were in continuous conversation with them both the 6 period of time that I worked with them through while I was back in Hyderabad. So I fortunately I got an opportunity to work at the client location. So they applied for H1B visa. H1B visa is a lottery type visa, not as if in Canada or some other countries where they go by merit based or point based system. That is, I think in Canada they look at they give you points for each and every thing that you have, your age, your IELTS, that is English, what sort of work you have done, how much experience you have, your family, do you have kids, all those accumulates to certain points. And if you actually cross certain limit, they'll actually invite you into the country. That's how rest of the world works. But fortunately or unfortunately, US works on a lottery system, so you have to put your name into thousands of employees who would actually want to go to US and hope you actually get picked up. So fortunately for me, I got picked up, and I had to attend an interview, a visa interview, and could get through that. And so I landed in USA in 2016, and from 2016 to 2018, I've got an opportunity to actually good opportunity to work at client location and interact with the client face to face. So that's one good opportunity that I have. And after that, I actually changed my genre itself to GE Renewables. So before I go to that, uh, uh, to sum up the whole experience that I have with Pratt and Whitney, it was actually a bit sort of we used to be proud for us to be working on some technology that's still not out there. And when you come to aerospace, it's always I think put on the pinnacle. It's always on the top of the pyramid when it comes to a feeling as engineers, as students studying it of engineering. When you say aeronautical, so I we could actually what to say feel that when we were working on that, we are working on a high end technology. That's one thing that we had. But the unfortunate situation of aerospace industry is that uh, as citizens of India, being studying there and brought up there and doing our jobs there, we don't have a company back in India which does produce aircraft engines, because our indigenous aircrafts, we don't have a first of all indigenous company that actually produces aircrafts. We have Hall, Hindustan Aeronautical Limited, which actually has Tejas in their bag, but that too uses a GE engine. So we don't have what we say indigenous Indian jet engine to work on. and saying that I think Tata and Mahindra are getting into aerospace, but they are in a smaller plane sectors where they have propeller fans and stuff. So nothing big on site. The huge thing, the huge advancements that were done in India were the Tejas, and I'm very proud of what HAL is doing. But unfortunately, we don't have a government organization or a private organization actually producing an indigenous Indian jet engine. So what happens is that if you really want to work on the cutting technology of the future coming to aircraft engines, it's only the foreign companies that you can take support of, that is Rolls Royce or Pratt and Whitney or GE or Siemens. These are the companies which have the big names in aircraft engines. But unfortunately what happens is that because they're a foreign soil companies, they don't want us as foreigners working on technologies that would reveal their dominance on the aircraft industry. So they would only give us a certain sector of work, which is dirty, I guess. So just to mesh, clean, just apply forces and give it. But the real technology where you have to take the decisions, where you know the in-depth problems of the product, and you can actually indulge yourselves into something innovative that might not happen in aircraft industry because of that situation where foreign companies restrict themselves in providing all the information that they have. They're a bit of paranoid. I think it's nature to be that, given the situation in the world where air power dominates everything. So if it comes to war, if it comes to business and everything, air power dominates everything. So they want to keep their dominance in their pack. They would only give you certain information that you can work on. You can't actually work on everything. So during that 6 years, I didn't see a part that I worked on. So that's very saddened. That is, as a mechanical engineer, that's one good thing that you have compared to other engineers. Not totally other engineers, but mainly IT engineers. That you have a product that you can work on, and you can feel the product that you worked on. So if you work on a phone, you can actually feel the phone. If you're working on a bench, you feel the bench, that you modified the bench or doing something like that. But unfortunately for me, for those 6 years, I couldn't get a hands-on or a look of the product that I worked on. It was always the UG or ANSYS, through the lenses of UG or ANSYS, that I had to look at. So that was my experience of my first 6 years of CAE or engineering, as engineer in the engineering. Apart from that, what we say, education background. And coming to my next, so after that, after a couple of years in US, working in US, I had an opportunity to work with GE Renewables. So it was a total different sector that I'm working in. So previously aerospace and now renewables. So in renewables, what the role that I played was to help service engineers. So basically, what happens with these turbines is, in USA in particular, you'll have a lot of hurricanes, you'll have a lot of storms, which would actually, what would happen in storms is that because of high winds or cyclone winds, the blades, the big blades that you see, might actually rip off and crash down. So that will not be a problem. They will actually replace your blades. That's not a problem. But what will happen is, when they fly out, if the blades are gonna hit your tar, okay. Now the question comes: can the tar continue to to be in service to the total life that it was expected to be in? So you can simply say that you can change the tar. But the problem would be, when I'm saying tower, I hope you understand the long stem on which the total, what we say, the wind
Engine
turbine
will
stands.
place. Hmm.
So what would happen is, you can simply say, we can actually change the tar, but the logistics involved in changing the tar or replacing the tar would be a big burden on a company. So not only the material, not only the personals involved, but to have a crane. Like imagine to actually put this big giant tower in place in the middle of nowhere, because you expect the wind turbines to be somewhere in the forest or somewhere in the fields, out in the rural area, isn't it? So to get a big crane to that location, to have everything assembled to take down the star and everything, would be a big expenditure. To it will be in millions. So that's where we come in. So what happens is, previously there were euro codes, manual codes that they would refer to. So they would actually refer to the dents. So what happens is, when the blade rips off, it actually dents the tire. So you have to know if the dent is fatal for the tire or not, to continue its operation. So previously what they used to do is, they used to rely on euro code, where they used to predict the length and width of the dent, and just say if it is viable or not. But that was a crude and very conservative thing. But given the what we say, advancements that we've got into CAE, and the advancements we got into other softwares, it was it was evident that we could actually exploit a bit more into the tower by doing CAE and stuff. So for suppose, the only parameters that were excuse me the only parameters that actually decided if the tower actually can stay or not were just the euro code. So it was just the size of the dent, width and the length of the dent. But if you understand, okay, if you go to a banana tree, okay, and take a axe and chop it exactly, what to say if you chop it vertically, you still see the banana tree standing, isn't it? If you chop it off over the trunk, along the trunk in this way, so what will happen is, then you actually the banana tree falls off. So those sort of, like, the general thinking of how the dent formulates on the what we say on the tower itself, and how does it damage, and how does it buckle, was not taken care. So I think those things that we could were the things that we could exploit, and prove through CAE, that we could exploit the tower even more. Even if the Eurocode says it can't, there is more conservativeness into those scripts. So we can actually do CAE and show them that we can save millions of dollars and still be in a safe zone, and not to replace towers. So that was the holistic work that I was doing back there when I was in GE.
Yeah, Arjun,
And
I have a doubt here, Arjun. Sorry to interrupt. So you're talking about the tar and the crack analysis of the tar or something, fracture, whatever it is.
no,
So
it's
how
just the buckling analysis.
buckling analysis? So are we going to do something like non-linear buckling and so is it comes under explicit analysis or how it will be?
No,
Is the tar?
basically, first
Mm,
people used to do just a buckling analysis. Okay, if the tower is good and fine, to really know the strength, it is buckling analysis. You can just have a beam,
mm,
a force, and you can just understand the modes of your buckling, and understand the force that it would require for us to buckle
mm.
transversely and longitudinally. But when it comes to dent, generally we used to do nonlinear analysis with material. That's because we wanted to see the extent of
Yeah, how it will reach
target. Yeah,
the
how,
SS.
how how much force it can actually get through. So that was the extent that one we
Mm,
wanted to see. So we had what we say, nonlinear materials, nonlinearity on, and geometric nonlinearity on in the models, and we used to fine mesh those parts, and we used to properly have the dents. So to get into details of that, like we used to have. So when I started off with that industry, the script was not something that was previously proved. We were
okay.
actually going with the flow. We were learning how our script behaves, what sort of elements that we use. So and there was no, unfortunately, there was no practical solution that we had, the practical experiments that we had to which we can fall on
Yeah,
and
which
say
is
that we
highly
are
costly,
good.
definitely.
Yeah, so that was in progress, but unfortunately, I came out of the company before that experimental analysis could done and match our this thing. So, but we were talking to experts to see how well we could actually simulate the realistic conditions in static analysis. So, dynamic analysis was something other. That was another burden that we wanted to take, but as I said, unfortunately, I had to come out of the company before that all development went on. But I was in the initial stages of the script development and stuff, but I had a lot of help from people from different various streams of engineering in the GE. So that's what we done, Sundar.
So what about the material details of the tower? On what
It's just
material it
aluminum.
is? Is it of composites of aluminum?
It,
Aluminum.
it's aluminum. Aluminum.
It's just
That's all. It's a big aluminum tube.
okay. So is there
So
any, I mean, limitations of the weight and all to carry and
no,
it may, no.
see what
Okay.
happens is
Whereas in
sorry.
Pratt, we have to consider about the weight because it is an aero. Am I right?
Yeah, yeah. So basically,
Yeah.
when you change industries, see, for
Mm,
suppose I'll give you a simple example of. I think that I can't let I think FT 400 or something like that. I'll, the example that I would like to give is I think when you compare aero to
wind
the
turbines.
wind turbine, it might not give you a whole picture, but just to let you know, there are a lot of aircraft engines that were grounded, that were taken out of
Mm,
service and actually, or else the are modified to be a ground power generating engines. Okay,
mm,
so when you sort of try to change aircraft engine to a power generating engine, the main
mm,
factor that comes is weight, as you pointed out. So when it is flying,
mm.
because every pound of force that the engine produces has is actually to lift and push the aircraft, and because it's in
Yes,
air,
yes.
so every pound that you put in as a weight is something a burden to the engine itself too, because that's what is powering the whole aircraft. But when
Mm,
it
mm.
comes to ground, because it's grounded, you can actually put anything on it, put a rhinoceros on it. I don't care, but it has to work, that's all.
Okay. Yeah, here
So
I have one more question is when you're changing the industries, so what difference you have first? That means the basics, whatever you have learned, remain the same. So if you understand the problem, will it remain same? How it is beneficial if you're changing that means you have got lot good exposure on various industries. So how did you face any issues for jumping from one industry into another industry? Or if I'm there, for example, okay, if suppose I don't know CAE. Okay. So I have started learning CAE and FEA modules. So I worked in aero industry first. So then if it is of wind turbine industry or oil and gas industry or healthiness industry, so we are changing the industries. The applications will be different. So the knowledge what we gained, how it will be beneficial in
okay,
different domains.
to answer this, I'll let you know. For suppose there is a the features might look different. Okay, the features might vary in the geometry.
Mm,
For suppose coming to aircraft industry, they might be just as a fist of my hand. Okay, when coming
mm.
to what we say wind turbine industry, they might you might look ant size type in compared to the total turbine. Okay,
Mm.
the geometry might change, the materials might change, everything might change, but the basics stays the same.
Yeah.
The cantilever, the for suppose if I take a cantilever approach to explain something in aerospace industry, will still be the same cantilever when you come to what we say, the wind turbine
Even in wind
industry.
turbine
So
industry. Yes.
exactly, for suppose if you take the blade of
Mm,
the wind turbine,
mm,
that would be of enormous gigantic proportion, but
mm.
still it can be explained by a simply supported beam. Constraint on one end, free on the other, you're just applying the forces, let it be aerodynamic forces or whatever it is. And coming to aircraft industry, a blade, a blade inside the what to say engine, let it be compressor blade, let it be turbine blade, whatever it is, again, it's small. Okay, it can be this small to this big. Okay, but still the same cantilever applies to that the same thing. So basically what I understand is CAE or UG and everything are a tool or a weapon. If it is not in trained hands, it is not of no use. Okay, if you give a child a knife or a AK-47 or a big missile or something, he can't do anything. He just misfires it and causes damage, that's all. But if it is if a small dagger, if you have a small knife or a small screwdriver in a what we say basic well developed engineer, it would make a world of difference. So learning UG, learning CAE is a big thing because you have to have the tools. You can't go into this modern world not equipped with any equipment. That's for sure. But you have to be skilled because in answers, it gives, until unless it gives an error, you can solve anything. Okay, you can have any sort of numbers. You can actually what we say you mistakenly give your different dimensions, it will give you answer. If you mistakenly put a different force, it will give you an answer. If you mistakenly mess up your theory, it will give you an answer. Okay, so answers will solve whatever you give it. So it is said garbage in, garbage out. So you put garbage in, it will give you garbage out. So basically to even before you have or with the CAE knowledge or with the knowledge of the current technologies or current softwares, you should be a warrior to actually hold or wield the sword. So that's how I can put it up.
Yeah, it's an excellent explanation.
Yep. Thanks, Sunita.
Yeah, yeah,
Uh,
yes. Yeah, you can explain
so
about healthiness. We have some questions, then we can answer to those. Yes.
you want to go with the questions before I continue?
No issue. Let us complete this healthiness first.
Okay.
Then we can.
So yeah, thank you, Sunita. So after this, after that, in 2020, I had an opportunity to work with Siemens Healthiness, and these guys actually work on they have wonderful machines. So basically, if you go to a hospital, you generally doctor orders for blood report or your urine samples or anything that has to be tested. So what you do is you go and give your blood and come back. But after that, what happens is generally a person goes, adds some chemicals, draws some numbers, and prepares a report. Okay, for your analysis to be done. So what Siemens has done is it has automated everything after you give your blood. So it can go into certain compartments. It can do mix materials, mix chemicals and stuff and everything, and actually get through reports and give you report. So that's the whole holistic general overview of what Siemens does on the picture that you see. That's the Italica. You can get it on off internet. So it has different compartments as sample handler, CC, and IA and everything. So basically. It actually gives solutions in solving medical problems of handling a large amount of what we say inflow of specimens and stuff to get those analyzed. So I had an opportunity to work with them for past 1 year. Fortunately, I was in sort of a R&D sector where we had a problem and we are solving it. I don't because I'm in the same company. I don't want to go in a bit deep about what really is. It's pretty interesting, but unfortunately, I'll not be able to share the whole details of what I'm doing currently. So it's a pretty interesting job. It's a bit of change of pace from the last two jobs that I had. This is from the past 1 year. It's rarely been that I've actually taken the help of a software. So, but it was more of physical work that I had to do, interpreting the results, doing a realistic situation and everything. And just to elaborate on the previous question that Sunita was basing on, that how important CAE is. See, basically, as I said, it's all CAs are garbage in, garbage out. Okay, until unless you are equipped to understand what you are inputting, you can't and interpret the results. It doesn't really make sense. So taking that into account, now also I don't think because of the variety of options that are present, variety of ways that you can approach a problem, and the way that you are trying to interpret the nature. Okay, so for suppose if you just take an aerofoil, okay, aerofoil can be from the preliminary analysis, take the blade of the turbine itself, from doing a preliminary analysis as taking just as a simply supported beam, applying the force, or else having the proper geometry. Next step would be having the proper geometry simulated, then putting the force. And next step would be having the proper geometry, proper material, and putting the force. And next step would be proper geometry, proper material, proper composition, proper force accumulation. So you can go into deep, and you can't really to predict really how nature does. Nature is a complex thing, so you're trying to predict what nature does. So there are many ways, simplistic ways to complex ways that you can do. So always the CAE results have to be, and most probably are to be supported with hand calculations. If there are simple calculations as cantilever, you can put into a cantilever beam or simply supported beam, you can. But if it comes to very complex situations and complex calculations, complex materials being added, it was always preferred to have experimental results to support your problem. Okay, for suppose if you predict a rod will break at 100 newtons, okay, and you do a realistic test, and it comes to 98, 99.8 or 95 newtons, then you can go back to CAE and see what more you can do in CAE to come to as realistically close as possible in real life. Okay, so that's what you're trying to do in CAE. So I think that's what sorry, I think a bit derailed again. So coming back to my experience in healthcare, so it was totally different. I was not working on CAE, but I was getting back to my concepts of basic of thermodynamics actually. So the first 6 years I was mainly on the
Strength of material.
structures sort of environment. And the past 2 years I've been working a bit of more into thermodynamics, mix of electronics. So because this is a small part with electronics and stuff, I have to work on fans, TEDs, the thermal conductive devices. I have to work on what we say DCMs. DCMs are where you actually have interaction between what you need and electronics. So those are compartments, just to crudely put it out. So apart from being a mechanical engineer, I have to know basics of electrical, electronics. So just to summarize, what I want to put out there is that to just to base and elaborate on the first question that Sunita had, what subject how you have to learn more. You might not, you might need electrical experience, like what I'm working with now, I have to understand, because the mechanical component that I'm developing actually works with an electrical components in hand. Okay, see, you can't develop a phone, okay, because mechanical engineer is needed to actually analyze the strength of this and everything, but there will be electronic components into it. Okay, for suppose if you're developing a fridge, okay, you're modifying a fridge, or you're modifying an oven. Okay, there, that is an electrical component, electrical and electronic component, but you are, as a mechanical engineer, you are helping them out. But you have to understand the basics of electrical engineering to communicate with electrical engineer and get the product out. Or else, if you're working somewhere like the wind turbine, a civil engineer is something you would like to conversate with. So it might not be mechanical engineering itself that you would actually be working or getting along with. Okay, in this world of what we say, where we are right now, in this competitive world where we are developing cutting edge technologies, or in any field, let it be aerospace, let it be what we say Healthyness, or the wind turbine, it might not be just the mechanical engineering that you would fall back on. You might need to know what is voltage, you might need to know what is amperage of parts, what different countries do with different what we say, regulations. So it's you might need to study a bit of law also sometimes, because if you are making a product in USA and selling it to China or India, you have to adhere to the laws that you are laws of the countries that you're selling to. So you might need to know as an engineer what sort of constraints that you have when you are developing. So you have to read to some legal documents, or so you in this world, you can't just be an engineer, or you can't just be a mechanical engineer. You have to be a person who can bring every person into your box and make a holistic understanding of product, and then give a solution. If you're just a mechanical engineer, you would not grow into the ladders. You will be in that laborious work of cutting things, meshing things, applying things, and that thing. But when you start conversating as a leader with different groups, so when you get into industry also, when you get into job also, other than working what you are being assigned, please be vigilant of what other groups are doing, what the IT group is doing, okay, what the electrical group is doing, or what the design group is doing. Just have a conversation, just make friends, just know the industry. Then you would be above everyone and be a leader than just being a follower and just doing the work. So
Okay.
that's how I would like to put it, and just conclude that.
Yeah, thank you. Thank you, Arjun. Thanks a lot. I would like to just summarize what Arjun has meant. So, first thing is, first, whatever tool we are learning, we have to learn along with the basics. Without basics, just learning a tool is just not knowing actually what it is. Whatever garbage it is giving, we have to accept it. So, for that, we have to understand what we have to learn. So for that, basics are important. And again, which basics is again is a question mark. So for this, I would like to correlate, as Arjun said, one of the point. As a doctor, for every each and part, there will be a specialization. But as a doctor, he should know some of the aspects as a complete body to understand how the other part is acting. In the same way, engineering, only one subject won't go alone. All the engineers has to be intact to complete any of the models. Like if you take a wind turbine or so, a civil engineering is required, and you can see a mechanical engineer is required, an electrical engineer is required to handle the data, might be an IT engineer is required. So all together only will generate the product. So how the doctor specialization is, in the same way, in an engineer also has different specializations where we are focusing on. If we go in depth, as he is saying, again there were so many conditions and so many aspects are there which we need to work on. So the thing is, whatever basics you can see, also in BTech we'll have some subjects. As a mechanical or a civil student, you will be having some one or two subjects on electrical or mechanical. And in the other case, in first engineering, basic drawings will be there for all the commonly for all the branches. So if you take strength of materials, civil engineer will have, mechanical engineer also will have. The formula for civil and mechanical will remain same. Might be the application may vary, okay, but still there also the cantilever beam, and here also the cantilever beam. Okay, so we have to understand where we are applying. That is what Arjun is mentioning. So now coming to the questions, you have some questions, like I will be answering one by one, and me and Arjun. So just to give me a second, I'm just segregating the questions. So first question I got, certifications of mechanical tools like ANSYS. Unlike IT, in mech or any core in civil, mech and electrical, people will check the knowledge, not on certifications. But still, we will provide you the certificates for the completion after finishing his assignment with us. Okay. And Priyosha is asking, basically he is a structural engineer of civil. So he is very much interested on FEA. What is the future growth for civil on FEA? Priyush, you can take me as best example.
Sunita, I think you're muted.
Yeah, sorry, by mistake it happened. So you can take me as best example. I am a master's from civil engineering structures. I worked in aerospace industry, wind industry, and various industries in car industry. So as repeatedly we are mentioning again and again, the basics will remain constant in any of the domain. As per the physics, we have to understand what it is. Tool will always act as a calculator. The correct formula we have to give as an engineer. To know the correct formula, we in our term, we are always providing, not the tool. If you want to learn only tool directly, we will say that go for YouTube videos directly. Okay. So rather, we will always train the students with the technical knowledge by giving more various applications or various understanding, and by the end of the course you should be able to, by seeing any project, how you can correlate what is the physics of the project and how you can simulate. Simulation by using a tool is always like a calculator. If you give correct formula, you should not check for a plus b and validate the answer for a minus b. Okay. So I think, Priyush, I have answered your question. So which tool is best to learn in India? In India or UK, whatever. So Arjun, will you answer this? Which tool is best to learn? I think, yes.
Yeah.
Yeah, Arjun. So which tool is best to
So,
learn? Yeah.
see, it's
It
so
gives
it depends on.
as our
Hello,
interest. Yeah, yeah. Yes.
hello. I'm
Yes,
audible.
Arjun, we could able to hear you.
Yeah, yeah. So it depends on what sort of industry you're getting into and what sort of work you would like to do. So if you want to be a what we say a designer, first of all, it might be UG or CATIA or something like that. See, for suppose I'll let you know, if you are learning UG, okay, and you want to transit yourselves to CATIA. Now, what different it will make? For suppose if you want to create a block, okay, what you do is you draw a square and extrude it. Okay, if you want to have a cylindrical what we say extrusion with a hole, then you draw a circle, extrude it, and draw another circle and subtract it from that, so that you get a sort of pipe or sort of thing. Okay, now in UG you would do that, in CATIA you would do that, and anything you would do the same thing. The thing is, you need to know where to do, where to click, or where the option will be.
Options.
And
Options.
and it is not like it's not like previously 10 years back it would have been very difficult to actually navigate through what we say programs and stuff, like any things, like you need to know really commands or properly know where it is located and stuff. But nowadays it is the softwares are being made so robust and so easy that fresher could actually access. If you know what to do, if you want to build, you'll have YouTube videos and you'll have what we say softwares, you can get through that. But basically what I say is, first of all, learn the basics. And if you are at a certain Hyderabad, okay, scope, if you want to do a job in Hyderabad, or if you want to do a job in Bangalore, or if you want to do a Bangalore and Pune, scope the area, know which companies are there, who is hiring, what they work on. Just talk to the get into
Expert.
LinkedIn, find people. Okay, try to understand what they're working on, what sort of tools are they working on, and try to learn that and expose your this thing. Okay, it's not.
Yes.
It is not like a bit of what we say is, if you learn UG, you have to be in
Hardcore.
UG. Okay?
Yes.
If you learn UG, you'll get a job. It's not like that.
To
Okay,
add
so
upon one more point to what Arjun said, first, not only the location, you have to fix your dream job also. According to your dream job, you have to work. So, as you can see, Arjun has taken as best example. See, he has worked in various sectors where the basics remains the same. So what the thing is, first you ensure what your dream job is, or ensure your location, fix the factors according to your circumstances, then take a tool.
So if it comes to aerospace industry, answers, knowing basics of answers, because no one can teach you what is being worked on. Like the basics is what we can teach you, and I think there we can make you strong. And the first 2 years of your job can be made easy, knowing that thing. But as you go on into your experience, you will learn a lot of things, and you will actually be mechanical engineering is sort of a wine. So as it ferments for years, the what we say, the knowledge or the price of the wine actually increases. So you can actually put some analyze like that. So yeah, know your industry, and then get into your perspectives.
Okay.
Here I have one question, Arjun. So we have two types of tools, like one is design and simulation. Which one is best?
Okay, so now that's what we say, fighting this thing. Like you you can't ask an engineer what's best. It'll start a riot. So you for a product to be developed, a design engineer is as much as required as analysis engineer. But now the sword with two edges is very much preferred than small this thing. So to have a knowledge of UG and also have knowledge of analysis, that would be a cutting edge thing. See, you then you would be owning the part. Okay, so for suppose coming to aircraft industry, it's a big industry. So you would have a particular group that would work on UG, and you would have a particular group that would work on answers, that is particularly on design and analysis. But coming to US, basically in US, when a part is given to you, a problem is thrown your way, it is expected that you would design, analyze, and give a solution and get to that. So in that process, you need to be a design engineer and analysis engineer, and that is what we say.
Is an
You can say,
architect role. Architect role.
yeah, sort of thing. That's where you have to get. You can start off with anything, but you have to end up being an architect, as you say, commented.
So,
Yeah, that means basically we should have both the design and simulation knowledge, at least to minimum, to access our product, how it will be, and if we need some changes, how we have to make.
so then he
Yeah.
will act as
Exactly.
an architect, and he will get the more salary when compared to the design engineer and
Yeah,
simulation engineer.
that's obvious, isn't it? Like when you are doing two roles, you will definitely have a preference.
Yeah, that's what. So he will be the backbone of that particular project.
Exactly.
And
Yes.
So basically, when you get into experience, you will have you will have people who can help you out. You will have people who will support you, but you should be in a position to understand when they provide you support. Okay, so for suppose if you are making some dish, okay, if people are there to help you out in cutting tomatoes, cutting everything else, and giving you, but you don't know what to make of it and when to put into the pan, then that's also a problem, isn't it? When going into the company, you might start off with cutting your vegetables and collecting your what we say, all that is required to cook. But in growing into the mechanical engineer, what will happen is after some time, as I said, as you ferment your wine, it'll become more what we say, experience. When you become more experienced, you will know when to add ingredients. You should know that you'll get into that whole range of accepting the help and giving your solution.
okay, one final question, Arjun. So how to get expertise on any specific tool as a fresher?
Okay,
Because
so
nowadays every company to reach out, they will asking for the expertise in the specific tool or else experience. So how to get that one as a fresher?
exactly. I think that's something I've been questioned a lot as when I was talking to young engineers, or myself, I had that question and stuff. So how I see, I might be wrong, but this is how I see the situation. Okay, every company needs experienced guy, and we don't have experience until a job is offered to us. So that's a problem. So how I saw this is basically, if you get take a theoretical sense of, if you are a student of an IIT institute, okay, you would directly get into GE, okay, GE developing engines of their own. So that's an OME who has their own product working on engines, hands-on stuff. You would be a GE employee if you get out of from IIT. Okay, IIT, MTech IIT. I'm saying if you are BTech IIT, you're nowhere to be seen. Okay, but MTech IIT, you would actually get to directly GE and stuff. I think I can take example of Sunita madam itself. And next step is me. Okay, I got off from a second tier college of IARE. Okay, and because of my college status, I could get into as a fresher into Scient. Okay, and after 5 years of experience of Scient, GE would be interested in me and pull into GE. Okay, I can't get into GE after my college. Only Scient would be interested in taking me, but GE would be interested in taking me only after having 5 years of Scient experience. Okay, if you're out of your fresher tag, or if you're of a college which the company is not interested in, then you have to find a company which is interested in you. Let it be a small company in a Balnagar area. Let it be a small company in something, but gain experience, have some experience done. Okay, so now you can find a company somewhere in Balnagar or somewhere which would actually work on some design aspects or UG and some such stuff, and work for them for 2 years, and then Scient would be interested in you in taking, because you are experienced for 2 years. Then after Scient, you work for 4 years or 4 odd years or 3 odd years in Scient, then GE would be it would be interested in you and you get into GE. But definitely fine, there will be some company or the other. Don't undermine what sort of company it is. But unfortunately, if because of your college or because of your educational background, or because of the fresher tag being going on, if the company that you are interested in or the dream job is not interested in you because of your experience, find a company which you are not interested in but gives you an adequate experience, such that you are interested, the company that you are interested in actually recognizes you and pulls you in. So that's how I see it.
Yeah,
So if you're an
yeah,
IIT
Arjun.
MTech graduate, GE would take it. If you are
Yes,
IR like me, Scient would take it. If you are a company, a college that is newly inducted into what we say BTech or stuff, some company would take your help and build your experience there and climb up the ladder.
yes, yes, absolutely, Arjun. Whatever you said, it is absolutely correct. To add upon on that, if we are making as per industry standards, we may get directly through Scient. Those things at our times it is not there because there were no proper guidance who are there to give to us.
Oh, really? Okay, that's nice. That's nice to know. So you
Yeah,
can, you are saying that if you are properly trained, then Scient would
yes,
actually be interested in taking you.
definitely, definitely,
Oh, that's
definitely.
nice.
It depends on how we are performing in our interviews and how much
Okay.
knowledge we have. So
Okay.
directly, so many people are reaching our company, to say academy, to give the proper profiles, but unfortunately we are not having exact profiles to match them, because
Okay, understood.
always there is a gap between the education system and the companies.
Yes,
So
that's for sure.
that we have to make educate people and fill it up. So coming to
Exactly.
Priyush, one more question. We are talking about basics, right? What basics means, it is not about FEM subject or something matrix calculations or software. Basic means how you are correlating a real life scenario problem in a system, like how you are using your like whatever in BTech
Uh,
you might be doing it like UTS,
Sunita, can
algebraic
I give an
tensile stress.
example?
Yeah, sure.
Okay.
Sure,
Taking
Arjun.
my experience into account, I'll just like to give you an example, Piyush. So,
Yes.
the tower that I was talking about, okay, that was being shipped from the shipping port to the place it should be installed. Okay, and now the tower is being carried by a big truck, and it is supported on two ends. Okay, on the far two ends, it is being supported. And what the service people or the installation people have complained is that they'll be, see in that big tower there'll be a big ladder to get onto the top, isn't it? Like generally you have to get onto the top, you have to work on the what is hub and everything. You have
Inside
to
the
climb
tower,
up
we will be having a ladder. Yes, absolutely. Yeah,
ladder.
correct. Mm.
Okay, so it is so tall that you have to take some rest, isn't it? So there'll be platforms at regular intervals. Okay, you can take rest on the platform, then again climb up the ladder or something like that. So what service people have, what we say, have noticed is that when the tower is being transformed, when it is assembled and being transformed from one location to another location on a truck, the platforms are coming loose. That is, they are breaking off from their hinges. So they've asked for a solution. Okay, so now instead of looking into this as a big complex problem of how the tube is being sent onto this one, and how it is a simple when you can really step back and understand and get into a normal sense, it's a simply supported beam. Okay, there's a big tube and there is a simply supported beam, but it's a what we say tube. Okay, it is being ovulated, and because it is ovulating, you are actually breaking off the hinges inside. So when you can understand the basics of how you can actually bring a complex problem into small things, okay, that's how where your basics comes into play. Or else, for suppose, if you are a HVAC engineer, that is what we say ACs and temperatures and stuff. Okay, you're in a house. Okay, and the owner complains that your window is always fogged. Okay, then you need to know. Okay, so you can refer to a psychometric chart. Okay, that's a basic. Psychometric chart is a basic. You know what is the temperature in the home, you know what is the temperature outside, and you know why it is actually condensing on the plate. And just tell the owner that just use defoggers, or just use that, just put it at a certain temperature to actually have that. Or else, when you know that, you will say that okay, you don't want to interact the inner environment with the outer environment, because you can't stop condensation, because two types of temperature are interacting with the window pane. Then you will come up with you have to isolate internal and outer temperature. Then you will try to find a ways. Then you will actually come up with double plane glass. So you have to fall onto basics why the problem is being caused. So that's psychometric chart, simply supported beams, or thermodynamic first 0th law. So those are small things. Those are first 10 pages of every book. So that's what the
Yes.
basics are meant.
Yeah. Yes, thank you, Arjun. I think Piyush, you have a proper answer from Arjun. Still, I will just try to end up in one word. You can see that, like what he is saying, the big part of the middle region, still you can make and correlate the same with a simply supported beam. That is how the basic is. That means where you can implement, the cantilever beams or simply supported beams or free body diagrams, all the mechanism or all the structures will almost depend on these factors. Okay, coming to matrix calculations and all, it's required to know how it is happening. It doesn't require to calculate manually.
No,
Uh,
if you are becoming an engineer who will actually develop the CEA, then you might need to know the basics of FEA. But I
Absolutely.
don't think, yeah. So it depends on your job. For that also, you might need to know what to say, the simple basics of the FEA, something like that. So the first, I'm telling you, the first 10 pages of every book will solve you a lot of things.
Yes. Among that, strength of materials and machine dynamics is, mechanism or design is very much important. Okay, we are ending up with the time. I hope all the questions were answered. You can speak up if your questions are not answered yet. If by mistake, if we are missing any.
I think all the questions are answered. So if
So
anyone is left with the questions,
yes. Right now only I think Malavya Sharma has posted. So I said you already, civil engineer with zero knowledge but has interest in CAE. Definitely, if you have the passion, you can achieve. So there is no need of thorough knowledge on FEM, but we have to have how the things are happening, how we have to interpolate. Okay, when you come to CAE, majorly structures other than buildings or commercials, everything will be done in FEA. Okay, to say frankly, in India, very less we are doing in ANSYS for civil engineer. Okay, but still we have very many options. where as a structural engineer, you can choose any of the industry, whatever we are specifying. You can see Arjun is the best example. He did mechanical and now working on a medico industry where mechanical things are needed. In the same way, in civil also, civil subject, if you have, so some are in other industry, we can use the same. Okay.
Just
Yes.
to add on that, Sunita, I've
Mm.
started. Actually, I was an aeronautical engineer by education.
Mm.
So mechanical engineer or aerospace engineer by profession for 6 years. Then now I'm
Wind turbine.
supporting
Yes.
medical team with
Medical
all this
needs. Yes.
electrical and everything else. So yeah,
Yes.
it can be anything.
It
See,
can be anything. Even I'm
I
also
was a
best
pretty average
example, as I
student.
said. See, I'm a structural engineer basically, then worked as an aerospace, and then now I'm doing so many projects related to automotive, and I worked on a little part of the wind and so many others. Okay, the basic in the sense, again, the strength of materials, to say frankly, that is important. Yeah, thanks a lot, Arjun. Actually, we have crossed already 10 minutes. Thanks for your patience, everyone. Hope this session is very beneficial to you. Thank you for participating. Thank you a lot. Bye, guys. Have a nice day.
Thank you, Sunita. Thank you, Arjun, for your wonderful session and for your valuable time. So thank you all who made this webinar success. So if anyone has any questions, please reach us atom.co.in, or else you can mail us like at contact@atom.co.in, so that your questions and queries will be answerable. And if you need any help, then we'll reach you and we'll help you out on that specific scenario. Thank you all.
Thanks, Sunita, for the opportunity.